Today we're going to take these logarithmic functions that we've been working with and see what they look like on the xy plane in a graph. So to show you this, I really want to go back to exponential functions first. My exponential function, I'm going to put everything in blue and work it down this right side. So with exponential functions, we went through the point 0, 1. And then we went through just a random point over here, whatever the growth factor was. We went through this point. I'm just going to call it 1b. And this was the point 0, 1. Okay. I drew a nice smooth curve. I know I had another point up here, but I drew a nice smooth curve that went through these 2 points. So from this, I got my domain to be -infinity to infinity. Got my range to be 0 to infinity. Remember, there was an imaginary line that sat right here. Okay, the graph came down and sat on it. Didn't cross it, but got close to it. That's my asymptote. That was at y equals 0. And then I had an intercept at 0, 1. So now what's going to happen with a logarithmic function is everything's going to get flip-flopped. Remember, exponentials and logarithms are inverses of each other. So what was my domain over on exponential functions is going to come over here and be my range. And then what was my range comes over to be my domain. Everything flip-flops to x's and y's, so instead of my asymptote being at y equals 0, now it's at x equals 0. Instead of the intercept at 0, 1, it is at 1, 0. So let's see what this will look like. If my asymptote has to move to here, and I'm going through the point 1, 0 instead, and then I just pick a random point. Okay, instead of going through 1b, I'm going to switch that around to b1. I'll get more specific on that b in just a minute. It is just my log base. I'm going to get more specific on it. And now I'm not going to cross this vertical asymptote just the same way I didn't cross the horizontal one. My graph looks like this. And it shouldn't be too hard to figure out how that got there, because remember, these are inverses. If I take this blue graph, my exponential graph, and reflect it over the y equals x line, it lands where this red graph is. So as you can see, there's a domain restriction on this. We saw that 2 days ago whenever we were graphing. We had to, when we typed in the natural log of -123, it gave me a domain error because this red line is not allowed to go over into the negative. Not only that, it's not even allowed to touch the y-axis. So there's a domain restriction on this, but the domain has to always be something that is greater than 0. And so that's the first thing I want to work with today, is finding the domain of a logarithmic function. And so this little 3-step process will get us through all of them. What I want to do is I want to set up an inequality. Okay, it has to be greater than 0 every time. What has to be greater than 0? The argument, which is what I'm taking the log of. There's going to be a lot of other things happening in the function. I'm just going to ignore that. Solve for x, and then as always, I want to answer in interval notation. So let's just find the domain. This is how your homework will start. It'll just want some domains, and they're going to give you a lot of extra information. But remember, step 1, I'm just wanting to set up an inequality with the argument. The argument is just what I am taking the log of. So this x minus 8 right here. So I'm ignoring the -2, the 7, the log. I don't need any of that. I just need what I'm actually taking the log of. And it has to be greater than 0 to stay on the correct side of the vertical asymptote. Add 8 to both sides, and I've solved my inequality. X has to be greater than 8. In interval notation, x being bigger than 8 is everything from 8 to infinity. And this is going to be my answer. All right, pause the video, you try part B, and then we'll see if our answers match. Hopefully you got your answer from 10 to infinity on that interval. Again, we're only working with the argument on there. Ignore everything else. So let's look at graphing We've got a domain restriction, so we're not going to have too much trouble with our domain. But I want to talk about the graph. It says draw and label the vertical asymptote. That's a good starting point, as long as it hasn't moved. Okay. A couple times it might move, and I might wait to draw my vertical asymptote towards the end of the problem. Steps 2 and 3, I'm going to combine those into a table. Remember when we did graphs of exponential functions, we plotted 3 points for my x's, -1, 0, and 1. Today I'm going to get rid of that -1 point, and I'm going to switch that 0 and 1 over here to the y side. And so what's going to happen is every single one of these that we're going to graph, I'm going to start with that point 1, 0, and then it says B1. That B comes from right here. I'm going to bring it down. And so the same way that I went through the point 1B last week on my exponentials, I'm going to go through the point B1 today on my logarithms. And draw a smooth curve, and we'll state domain, range, and asymptote on each one. Let's see what this looks like. So it says you can start with your asymptote. That's perfectly fine. This one's not going to be moving around yet. So it will just start right here on the y-axis. So I'm making my table, making a little XY table here. What's going to happen is I'm going to go through the point 1, 0 every time. Right here. And then I'm going to go through the point 7, 1 each time. Bring this B over, and this will always be a 1 right here. These two numbers will definitely always be a staple in it. So 7, 1, 1, 2, 3, 4, 5, 6, 7, and then up 1. So I connect. For some reason I use an X right there, and that point, and that would be full credit on this. The domain on this is restricted this time, so I'm not allowed to cross that asymptote. So it gets really close to it down here, but it doesn't cross it. So it gets right up next to 0, doesn't cross it. Then goes all the way out to positive infinity. The range every time tonight will be negative infinity to infinity. And the asymptote in this case is x equals 0. So of course I'm going to throw a translation in here. We got to move this thing around. We're going to squish it. We're going to move it. We're going to reflect it, and do all that fun stuff. So in this case, where I see that I'm moving it around, I might want to save step 1 for later. You could probably put it on there if you want to, but just realize the asymptote's probably going to have to move. So I'm just going to start with my XY table and my 0 and 1 over on the right side. So this first point's always going to be 1, 0. Right here. That point will always be there. And the second one, remember, comes from the base right here, this 4. So 1, 2, 3, 4. Landed right here. So you'd be able to see kind of how this graph is bending. But it's been moved. Okay? It's been moved. There's a -4 right here. So remember, it's opposite. So I'm usually think, well, let's take everything to the left 4 because it's -4. But instead, it's going to move to the right. Okay? It's inside the function, so it has to move left or right because it's inside the log, it's inside parentheses. So if I move both of these black x's to the right 4 units, 1, 2, 3, 4, and right here, 1, 2, 3, 4. And the reason I haven't drawn my asymptote yet is because I want to move it as well. So it's going to move to the right 4 as well. This ought to be full credit on my graph. Come over and tell me a little bit of information about the graph. The fact that it almost touches 4 and goes out to infinity. The range, you can put the same thing every time. But the asymptote moved over. 1, 2, 3, 4. So now it's at x equals 4. Okay, go ahead and draw the parent function on this one. Show me where it originally landed, and then show me where it moved to. And then hit play once you're done. Hit pause to start, and then my answer will be up there. now, careful on this one. I moved up 7 units, so that blue graph is way up there in the first quadrant. So it should be very easy for me to grade. I can see where your original x's were, and then you moved everything up from there. Now let's try one where we have to squeeze it a little bit. Okay, it's going to start off the same way. I see it's not being moved left, right, up, or down as far as the translation goes. So if you want to go ahead and draw your isotope on here so you don't forget it, that would be a good first step. I'm going to go through my staple point, 1, 0. It's always there. And then, oh, did I forget a logarithm, a log base on this? Or did you remember that it's 10? All right, so that 10 comes over, and it's going to be the 0.101. I don't like graphing just log base 10 of x because it puts this other point way over here. It makes it really obscure to graph. So I have these 2 points, and now I'm interested in doing the transformation with it. The transformation on this one, I have a 1/2, and that's on the outside of the function. Outside of the function, everything moves up and down. So in this case, it's going to get squished up and down. Everything's going to have half the height that it originally does, or it's being squished, so it's half the distance to the x-axis that it currently is. Well, if you squish something that's on the x-axis, it's just going to stay right here on the x-axis. And if I squish this point that's 1 unit away from the x-axis, then it's going to just be half a unit away from the x-axis. So this graph looks really weird. It's really flat whenever I graph it. Do the best you can with it. But nothing as far as domain, range, and isotope is going to change on this because it didn't move left or right. I'm going to let you try this one. I'll tell you what, just go ahead and take this one as far as you can, and then I'll graph the parent function, and we'll see if we can work it together from there. This one has a lot of transformations going on with it, so I want to make sure that you can pick up each one as we go through. Careful with this second point right here. Did you find that it was e, since this is actually log base e? And so remember, Euler's e is 2.7182, right? Just for graphing purposes, I'm just going to use 2.7. All right, so this +1 right here, again, it's inside the function because it's inside parentheses. It's much easier to tell on these what's inside the function, what's outside the function because of those parentheses. And so I have that +1 right there. I'm thinking to the right one, but remember it's opposite. So everything's going to move to the left. I'm going to take these 2 blue x's and move them to the left 1 unit. Now, since that's all I'm moving as far as left and right, if you want to go ahead and draw your vertical isotope, you can. Or you can save that fun for the end, whichever one you want to do. But I know it's going to be right there because that's as far as I'm moving it left and right. Order of operations says I need to take care of this 2 next before I do this vertical translation. So that 2 is just going to stretch everything. So it's twice the distance that it currently is from the x-axis. Well, if I stretch something from the x-axis and it lies on the x-axis, it doesn't move. This little red x right here, it's 1 distance, it's 1 unit away. So whenever I move it, I'm just going to make it so it's 2 units away. I'm just stretching it by a factor of 2. And finally, I'm ready for the -4. The -4 is going to move everything down 4 units. So I'm just going to take this black X, 1, 2, 3, 4. It lands right here. 1, 2, 2, 3, 4. It lands right here. And so I still have this same blue shape. It's been stretched just a little bit. But if you go through those 2 points, it should do the stretching for you. The domain on this one changed just a little bit. I'm picking up at -1 is my smallest x value that I touch or almost touch in this case. I go to infinity. And the asymptote also moved to the left one, so it's at x equals -1. Let's graph one more together. We'll make sure we're good on reflections, and then that'll be it for graphing. Now, there's not a horizontal translation on this. So if you want to draw your vertical asymptote now, you can, or you can save that for the end. I'm just going to save it for the end this time, just so you know that you can do it anywhere. So I'm going to have my staple point, 1, 0. And then my second point, 1, I'm going to bring this to here. So this time they're really close together. So if you wanted to draw that vertical asymptote, you can to kind of get the shape of it. But like I said, I'm going to save it for the end. Okay, I'm going to do everything on the inside first. So I have this negative on the inside, and it reflects it. Everything on the inside is left and right. So if I reflect it left and right, it's going to reflect over the x-axis. And so this red x will land here. This other one will land up here. Reflected over the y-axis. And finally, I have the minus on the outside, the negative. That's going to reflect it over the x-axis. It reflects it up and down. So if I reflect something that's on the x-axis already, it's just going to stay put. And if I reflect this blue x, it's just going to land right here. And keep in mind that my asymptote did not change, because I did not do a horizontal translation of just moving x's left and right. I actually just reflected them. And so keeping in mind that I have to get closer and closer to this green line without crossing it and go through these 2 points must mean that my graph turned around and it looks like such. Now careful with domain on this one. What's the smallest x value that I'm going to eventually touch? Well, it's going off the left side of my graph. So this time it's going to be negative infinity. And then the biggest x value that I touch or almost touch is 0. Range is same as it always is, and my asymptote did not move. Here's a review of just all the translations I did in this video. If you have any questions on them, they should be explained on here, but they are the same that we have done so far this semester.